I'm working on, or been working on, like for my data recently. This is data from the cameras, so each folder is one wavelength that I tested, so basically like one color of light. And you can look in one, and I'll pull up. Each one has 50 images, so they're all imaging the same thing, but I just imaged it 50 times so I can get some statistics on it. And then this program, there's a couple programs that I've built, but this one specifically, so there's two. One takes all those images and pulls the numbers out and puts them into a text file. And then this one basically takes that text file and combs through all the data to find the maximum of the data. So the peak was what I'm looking for. So you can think of it as like the brightest. If there's one pixel that's brighter than the rest, that's the one I want to find, but I don't know where it is. So I have to like reference, kind of go through and you say, is pixel A brighter than B? Is B brighter than C? Find that. So then this is set up. Basically this code grabs the file, opens it, and for each one of those 50 files, finds the brightest pixel, graphs it, and records it to a separate file. So when I run this, you'll see it'll automatically just start building these files for me. So these plots all look the same. There's one plot for each image that I took, and theoretically they all should be the same, but just because the sensor is a little bit different in different regions of the sensor, so then I could look at one, or I can go back and it builds another file that will pull up all of the positions of each peak. So that's 648 nanometers. That's the wavelength, so the color basically that the intensity peaks at. And if I scroll down, it'll give me, I also have it set up to calculate my average as well as standard deviation, which is the error. So basically how far all of these numbers deviate from the average, which is a measure of kind of how valuable these numbers are, or how trustworthy they are. Then from there, that number is for one wavelength, for one camera. I can calculate a difference basically. So this difference is how far different is the camera reading than what is actually true. So here, this is kind of like 6 or 7 nanometers. It's reading the color red as the color red plus 7 nanometers, basically. Something like that. So this would be the calibrated camera. That's what I'm doing.